Hey everybody, it's time for our next set of notes. Notes number 15, combinations of functions. And I do have news for you. This is our last set of notes in chapter 2. Okay, here we go. I'm actually trying to really simplify this lesson and give you the main ideas without going into a lot of detail because you could really get stuck out in the weeds on this one. So we're going to work with some simpler examples and kind of avoid the more complicated ones. We're going to start with adding, subtracting, multiplying, and dividing functions. So suppose we have f of x equals x squared plus 2 and g of x equals 3x minus 1. Let's add them. So we could write it as f of x plus g of x, but you might also see it written as f plus g. Or you might see it written as f plus g of x. So either way, it means the same thing. So all you have to do is add the two together, and if they have any like terms, then you combine the like terms. So in this case, looks like we need to combine the plus 2 and the minus 1. So we have x squared plus 3x plus 1. And that's the combined function that we get by adding the two functions. And you might also be asked for its domain, so then you could find the domain like we did last time. It's a polynomial, so its domain would be all real numbers. The same thing would apply if we're subtracting. It might be f minus g, or it might be g minus f. Let's say we're doing g minus f. So you just have to pay attention to the order. So g is 3x minus 1, and then we're subtracting. Make sure you put parentheses around what you're subtracting so you don't forget to distribute the negative sign. And so then we have 3x minus 1 minus x squared minus 2. And then we'll combine the like terms. And as long as we're rewriting it, we might as well put the terms in descending powers of x. So we have the opposite of x squared plus 3x minus 2. So that's the difference, g minus f. Now I'm going to throw in a bonus question. Is that function even, odd, or neither? That's right, good job. It's neither. And that's because just the quick check is it has an even power, it has an odd power, it has an even power, it has a mix of odd and even powers, so we know that it's not going to be either one. Okay, let's go ahead and find f times g. So it might just look like that, fg, or it might say fg of x. And you're going to multiply the two together, x squared plus 2 times 3x minus 1. And in this case, to simplify, we need to go through the FOIL process. So the outside is 3x cubed, or excuse me, the first is 3x cubed, the outside is minus x squared, the inside is 6x, and the last is minus 2. And then, I guess there's no like terms to combine, so it's done. What's the domain of that function? That's right. Since it's a polynomial, the domain is all real numbers. And then you might be asked for the quotient, so that might be either f over g or g over f. Let's say it's f over g. It might just say that, or it might say f over g of x. And in this case, we would have x squared plus 2 as our numerator and 3x minus 1 as our denominator. So remember, if you have a polynomial over a polynomial, it's a rational function. And you could even be asked to find the domain. And if that was the case, think about the denominator. Ask yourself, what makes the denominator 0? That would be 1/3, so x could not be 1/3. Okay, so we're combining a lot of ideas today. So I'm using the same two functions, f and g, in problem number 2, and this time, instead of finding the values in general, we're going to plug in a number. So you see in part A, it says find f plus g of 1. And that means the same thing as f of 1 plus g of 1. And so f of 1 would be 1 squared plus 2, and g of 1 would be 3 times 1 minus 1. We're just going to simplify that. So we get 1 plus 2 plus 3 minus 1. We get 5. In part B, it says find g minus f of 0, and that means the same thing as g of 0 minus f of 0. And for g of 0, 3 times 0 minus 1, we get negative 1. And for f of 0, 0 squared plus 2, we get 2. So negative 1 minus 2 is negative 3. Okay, in part C, we're asked to find f times g of 2. So that means the same thing as f of 2 times g of 2. F of 2, 2 squared plus 2, that would be 6. G of 2, 3 times 2 minus 1, that would be 5. So 6 times 5 is 30. And in the fourth one, we're asked to find f over g of 2, and that means the same thing as f of 2 over g of 2. F of 2 is 6, and g of 2 is 5, so this time we get 6/5. Okay. So here we have two different functions, f and g, and they're both rational functions. And we're asked to find f plus g. So we have 1 over x minus 3 plus 2 over x plus 1. I thought this would be a good opportunity for us to do a quick review of how we would simplify something like this if simplifying implies combine them into a single fraction, which is generally what it means. So we're going to need to get a common denominator. So in order to do that, I'm going to spread them out a little bit if I can. Let's see if I can move part of it over. Make a little space. Okay, we're going to multiply each fraction by a special form of 1. There's a 1. There's a 1. And the special form of 1 we're going to multiply the first fraction by is x plus 1 over x plus 1 because it's missing an x plus 1 in its denominator. And we're going to multiply the second fraction by x minus 3 over x minus 3 because it's missing the x minus 3 in its denominator. And once we've done that, we have a common denominator. So then, if we add the numerators, we have x plus 1 plus 2 times the quantity x minus 3 over our common denominator, x minus 3 times x plus 1. And then we're going to simplify our numerator. So we have x plus 1 plus 2x minus 6 over the quantity x minus 3 times x plus 1. There's no need to multiply that out on the bottom. And then let's go ahead and combine the like terms in the numerator, and we have 3x minus 5 over x minus 3 times x plus 1. Now there will be times, potentially, when you can reduce your numerator and denominator, but it doesn't look like that happens this time. Okay, part B is to find the product f times g. So we have 1 over x minus 3 times 2 over x plus 1. And when you're multiplying fractions, it's actually simpler than adding. You just multiply the numerators and multiply the denominators, and I'm just going to leave it factored. Now imagine we were also asked to find the domain of that. Remember, when looking at a rational function, you ask yourself what makes the denominator 0? So there are actually two numbers. This part of the denominator would be 0 if x was 3. So for the domain, x cannot equal 3. And this part of the denominator would be 0 if x was negative 1. So x cannot equal negative 1. So we'll just throw in that little bonus part of the problem for you. Okay, for part C, we're finding f over g. So we have 1 over x minus 3 over 2 over x plus 1. Okay, we have a fraction over a fraction. And we call this a compound fraction or a complex fraction. There's different words for it when you have fractions inside fractions. But just remember what you learned when you learned fractions with numbers. If you divide fractions, it's equivalent to multiplying by the reciprocal of the denominator. So this is equivalent to 1 over x minus 3 times x plus 1 over 2, the reciprocal of the fraction we divided by. And then from there, multiply the numerators, we get x plus 1. Multiply the denominators, I'm just going to leave it factored, 2 times x minus 3. Okay, what about the domain of f over g? Well, let's take a look at f over g. If you look at the final answer, it looks like the only thing we need to worry about is x equals 3. So we should say x is not equal to 3, because that would make the denominator 0. However, with this kind of problem, in the context of knowing what you started with, knowing that you started with two different fractions, we have to look back at the beginning before we simplified and ask ourselves, is there anything else that wouldn't work? Is there anything else that would make a denominator 0? So look at this one. If x was negative 1, the denominator of that part would be 0, so we have to exclude that as well. Okay, part 2 of this lesson is on function composition, and this is where you have one function inside another function. Or maybe even one function inside another function, inside a function, inside a function. It doesn't have to be only 2 layers. But we'll kind of talk about it in terms of 2. So it's going to look like this. F of g of x, if g is inside f. Or g of f of x, if f is inside g. But the special notation for that looks like this. F of g looks like a little o, and sometimes people say fog. G of f. This is what we say. F of g, g of f. And it doesn't mean multiply. It means one function is inside the other. You could also have f of f. You could put f inside f. You could have g of g, g inside g. You could have f of g of h. You could have all kinds of things. So let's look at this example. We have f of x and g of x. And we're asked to find f of g. Remember, f of g means the same thing as f of g of x. G is on the inside. So we're going to take 2 over x and put it inside the f of x function. We're replacing the x with g of x. So that's going to give us the square root of 2 over x plus 4. Now there's some things we could do to simplify that, but I'm also trying to keep this lesson short, so we're not going to worry about that right now. Just think about which one goes on the inside and which one goes on the outside. Part B is to find g of f. So for this case, let me get rid of some of my extra writing that I did there. For g of f, it means the same thing as g of f of x, like this, where f is the inside function. So this whole thing is going in for x in the other one. It's replacing x. So that means we're going to have 2 over the square root of x plus 4. So this is how we can build more and more and more functions. We just keep combining small functions together. Okay. Of course, we could be asked to find the domain of that. So just for fun, let's think about that. So we know we can't have a radical in the denominator. Or excuse me, we know we can't have a 0 in the denominator, and we know we can't have a negative inside the radical. So x plus 4 has to be greater than 0. So x is greater than negative 4 would be the domain. Okay, let's go back on track. Find f of g of 0, part C. So this means the same thing as f of g of 0 written like this. So we're finding g of 0 first, and then we plug it into f. So what is g of 0? G of 0, if you go back to g, 2 over 0, we have a problem. That's undefined. And f of undefined is undefined too. And then for part D, we have find g of f of 3, which could be written like this. Excuse me, g of f of 3. So we're starting by putting 3 into f. So what's f of 3? Let's look up here. F of 3, square root of 3 plus 4, square root of 7. So we put that in there. We put square root of 7 into g, which means that we're going to have 2 over square root 7. Now we could rationalize that to simplify it. So we would end up with 2 square root 7 over 7. Okay. And then wrapping it up here, here's another kind of problem you might do with composition. Suppose that h of x is equal to f of g of x. So h is made up of an inside function g, which is inside an outside function f. And we know that h of x is equal to x plus 3 to the 4th. What is f of x? What is g of x? So remember, f of x is the outside function. G of x is the inside function. So what do you think? There's actually more than one answer you could give. But what's the most obvious? What do you think the inside function is? That would be x plus 3. That's inside the parentheses. So what do you think the outside function is? Well, what are we doing with that inside thing? We're raising it to the fourth. So the outside function is f of x equals x to the fourth. So then if you put them together, you're putting x plus 3 inside and raising it to the fourth, and that's h of x. Now there are other ways to do it. You could get really creative. You could come up with other answers. For example, what if the inside function was x plus 3 quantity squared? What would you have to do with it to get h of x? You would have to square it. So f of x could be x squared, and that way f of g is x plus 3 squared squared, which is x plus 3 to the fourth. So there are many answers, but you don't have to come up with all the possibilities. So think about this one. We'll end on this one. Let's say h of x is the square root of x squared plus 1. H of x is made up of f of g of x. What do you think the outside function f is? What do you think the inside function g is? What's one possibility? So if you go with the most obvious choice, then g will be x squared plus 1. That's what's inside the radical. And f will be the square root of x. Or if you want to go with a more creative choice, you could say that g is x squared, and f is the square root of x plus 1, because you're going to stick that x squared in the position of x. So you have many possibilities. Okay, this takes us to our last assignment before the review.
Yay!
Okay, so here we go, and like I said, I've kind of simplified and just picked out the basics for you. I hope that's good. Thanks, everybody.